Yeah. So this is primary screen. So you can see the here ZOS. It is the operating system of mainframe, like Windows OS. How we have on personal computer, mainframe use this Z operating system. So here these are drives on personal computer. How we have drives? Here we have regions. We call it as regions. They are like logical partition of physical storage space. Okay. So I'm logging into this region, TSO region. So TSO, so my login ID is this one, may TSC, and so here you can, it will ask you to enter the password. So mainframe is, it is not case sensitive, means you can give user ID or password, either caps or small, it will not understand anything. So you just, so you can use anything, it will treat as normal only. So this is a primary screen, sorry. So here we use only keyboard to do anything, to type anything or to go to any screen. We use keyboard only. We don't use cursor. Just cursor, we just use to place the cursor somewhere, like to type something. If you want to place here, if you want to type here, you can place cursor and type something like that. But other than that, we don't use anything. So like double click, right click, say left click like that, it will not work here. Okay. So basic commands we use here are like, these are the function keys. So on keyboard, you have these keys, right? F3. F3 means to go back to from one screen to previous screen, we use F3. Okay. So F5 to find anything, any word, like in Word document, if you do Control F, we can find on Word, right? Like that here on mainframe, we use find command. So to find anything, we just use F space that word key, that word. So to repeat this find command, we just press F5. Okay, F7, this is used to like page up, scroll up on Word or anywhere you can see notepad, PDF. So to go down, go up, we use mouse also, we use right that wheel to scroll up, scroll down like that. So in mainframe, we cannot use mouse or the function keys. The page down, page up buttons will not work. So we have to use these buttons, F7, F8. F7 is like to scroll up, F8 is to scroll down. Okay, F9, this is another function key. So it is used to swap between the screens. So you can swap between multiple screens using this F9 button. Okay. So F10, it is like left, and F11, it is right. Okay. If you want to go left side of the screen, you have to press F10. If you want to go right side of the screen, you have to press F11 like that. So other than this function keys, we have basic commands. So these only you just need to know these function keys, and you need to know these commands. So other than that, we have line commands. So these main commands are like start. If you do start, it will open new screen. If you do save, it will save existing program or whatever in that PDS or PS file. So cut, it is like copy a normal system, normal, so a normal computer. So how we do copy, like select copy and paste like that. Instead of that copy, we use here command cut. Okay, it is same as copy on normal system. So cut paste. So this is cut means copy, and then we do paste. Paste means it's same, like you just need to paste the copied data. So columns, to enable the column numbers, we use columns command. And if you see any numbers, if you want to turn off the numbers, default numbers, you can use nums off, num space off. And to see keywords highlighted, you have to use the highlight on. Okay, so in COBOL, to see COBOL, all COBOL keys highlighted in different color, you have to give high cop. These are the command, basic commands. Okay, so these are the line commands we use. So you I will explain this later. So once I use, then I will explain. You can remember easily. Okay. So this is the main screen here. So we need to create a PDS library to code the program. Okay. Like I said, so we maintain data in two types of data sets. Data means data, normal data in PS files we maintain, and the program is also kind of that will need a storage space, right? Where we need to write the program, that all. So that all thing we have to decide. So we write the programs inside PDS data sets. These are nothing but we call them as PDS libraries. Okay. So this is main primary screen, ISPF primary screen. So this is this come with JDOS operating system. Okay. So how on normal computer, how we get this setup and also if you want to double click. So this all will come with operating system, right? You don't need to install any software for this to open any folder, double click like that. So like that with JDOS, JED operating system, we get these screens, this set of screens. These are called ISPF screens. So this is ISPF main primary screen, main screen. So here we have options here. Okay. To go to different screens, we have options. So we have to select these options and navigate through these screens. Okay. So to create PDS or PS file, we have to go to option three utilities. Okay. Perform utility function. So here you can see my user ID. I log in with Mate AC user ID, and you can see time, system times, the server data center time. So we connected to server, right? That server, the time at that place. Okay. So if you do just we have simple commands. So TSO time. So it will tell the exact. So it is same. The current time is 23:44 at their place. So it is like their midnight 11:44 p.m. That's central time. So it is nothing but our daytime. It will be, what is the time now? 9:20 like that. So we connected to their server and then we need to work on. So to write the program, I need to create a PDS library here. So I'm going to option 3 utilities, and then 2 is for dataset, to create any dataset, PS dataset or PDS dataset. So we have to go to option 2 here. Okay, you can see here utility selection panel. So to and the options to create the data set, we have to choose A. A means it will allocate a new data set. So if you select A, okay, these are limited options. We don't use all the other options we don't use, only we use A. And here on previous screen, if I do F3, F3 means back, right? I just told F3. So if I press F3, it will go back to previous screen. Okay, I came to previous screen here. So we don't use all these things. We just use these three mostly. These two for dataset creation, and we use 4 to see the existing datasets. So these two only we use here. Okay, I'm going to 2 here. If you press enter, it will take you to next screen. Okay, I'm giving A, allocate new dataset. Okay, so we have to use arrow keys and tab button you can use. So if I do tab, it will come here. The cursor will go like this. So tab. So here in codes, we have to give the library name. Can you all go on mute if you are not speaking? Okay, so yeah, so I want to create a data set. So for that, so each data set name should be like it should not exceed 40 character, that data set name. Okay, so let's use a so I'm creating a PDS library. Okay, this PDS dataset or library, we can call it library. Okay, so this name, any dataset name, PDS or PS, dataset name should not exceed the 40 characters. Length should not be more than 40 characters. Okay. Or we can say bytes. So as I told, we use the word byte for everything, for every character or digit or any symbol. We count that one digit or one character or one symbol equal to 1 byte. So this name we should not exceed 40 bytes or 40 characters. Okay. So and the name will be like this. So user ID or login ID and your name. So I'm using them. So my name is Krishna and uh, so library name. So I want to write COBOL programs, right? So I'm naming the library as COBOL. Okay, COBOL dot lib. Lib means library. Just I am giving. So it is user defined. You can give any name. But as per standard, to understand easily, so I am giving COBOL as one of the qualifier. So this total length should not exceed 40 bytes or 40 characters. Okay. So we separate the name like so we use periods in between each qualifier. So we call this as qualifier. So this is first qualifier, this is second qualifier, this is third qualifier, fourth qualifier. So name is a collection of qualifiers. Okay, 40 bytes. Like it can be like qualifier 1 dot qualifier 2 dot like this. You can have anything, but the total length should not exceed 40 bytes, and each qualifier length should not exceed 8 bytes. Length should not be greater than 8 bytes. Okay, or 8 characters. So dataset name should not exceed. You can give less than 40 bytes, but it should not exceed 40 bytes. Okay, like that, the standards we have. So I want to give the library name like this. Okay, so let's go to mainframe. So this is mainframe. So here, if you press home button on your keyboard, you can place the cursor and this first line option here. Here you can mention. So you can place the cursor. So if I do tab, it will go like this. Okay, so here under other partition are sequential dataset name. So we use this the name option under this. So name here we give the name in quotes. We have to use the quote single quotes. Okay, my user ID is maitc dot. So name Krishna dot. So COBOL dot lib. So this is my library name. Okay, it has 1, 2. So 1, 2, 3, and 4 qualifiers it has. Okay, it is moving when I click cursor. Okay, COBOL dot lib. Okay, end the name with single quotes. If you just press enter here, you can see next screen. So on this screen, we give the parameters like how much size we need to give this data set. Like so storage space. So based on this, it can contain the number of programs. Okay, so this volume serial for each storage space, a volume serial number will be assigned by default. Okay, so this when as per the environment, as per the software, we have to this will be provided by them only. We just need to use them what they provided. Okay, and then space. So here we give the space, the memory. Okay, so in general, if on phones you can see 1 GB, 2 GB, 3 GB memory like that, 30 to 16 GB memory like that. How we have memory in GBs. So on mainframe, we measure the memories in mostly in tracks and cylinders. Okay. So one track is it is like 1000 bytes, 1000 megabytes, one track is like that. So 1024 bytes, megabytes. So you know, right? So this general can, so like how we have so one byte is not generally it will like 8 bits. So we always treat the things in byte only. Okay. So here we don't we don't talk in bits. We talk in bytes only. Okay. So 1024 bytes, it will be like 1 kilobyte. Okay. 1024 kilobytes, it will be like 1 megabyte. Like that. Um, so 1024 megabytes, it will be like one track. Okay. So 1024 tracks, it is like one cylinder. Okay. So in general, what is like 1024 MB equal to like 1 GB, right? In general, but instead of GBs, we use here tracks. Okay. So instead of that, we use track, one track, like that. So we give the memory in tracks only. So tracks and 1024 tracks means 1000 GB, that equal one cylinder, like that. Okay, so basic measures, basic units we always give as tracks. Okay, so track I'm giving one the parameter we mention here, track or cylinder, like that. And here we mention the number of tracks. So 10. So primary quantity means primarily it will allocate these many tracks to this library, to this PDS library or PDS dataset. So 10 means it will allocate 10 tracks primarily, and then secondary quantity of, so after using these 10 tracks, it will use this secondary quantity. Secondary quantity I'm giving like 5 more tracks, or will give yeah, 5 tracks. So once using these 10 tracks, I want to make these 5 tracks available, like that. So directory blocks. So for PDS library, we have to give this directory blocks. Okay. So there is a little difference in PDS and PS while creating the data set. Okay, this is general for all, for any data set. So difference in PS and PDS is, for PDS data set or library, we have to give directory blocks greater than 0. Okay, this should be greater than 0. So as we can give 10 here at least, or 20. So record format, it is common. So these are common parameters. So I will use this in, so I will just keep this in here in Notepad for your reference. So volume serial, it is normal. By default, it will come with system and provided by the organization or admins. So whoever build the system, they provide the serial number. Okay, this serial number is assigned to the physical, assigned to the volume, storage volume or storage space. Okay, space unit, it can be in tracks or cylinders. We give these two ways we give. Cylinders is huge. If the tracks are not sufficient, we use cylinders. So generally for practice purpose, we no need to give cylinders. Okay, you always use tracks only. So primary quantity, so initial, this is initial unit, initial number of track, initial assignment, initially it will take. Okay, if this is not sufficient, it will use this secondary quantity. So after completion of this primary unit, primarily allocated tracks or cylinders, it will use the secondary quantity. And directory blocks, so this is for PDS library. So this is for PDS data sets. it will be greater than 0. Okay. And for PS files, so for PS datasets or PS files, it will be 0. Okay, so record format, it will be, so generally we use FB. FB stands for fixed block. Okay, so record format, so all records whatever we write inside this library, so they all they all have same length. So fixed block means their length will be same length for each record. Okay, it is same for all. And so other than this, we have fixed block and variable block format and unformatted things. So we don't use this variable block and we use this unformatted for special purpose. So I will explain that later. FBF stands for fixed block. We just remember this one only now. Means all records in the data set, inside the data set, have same length. Then record length. Yeah, this is the record length. So it is length of a record in the data set. So this is 80 means it means 80 bytes. 80 byte record length. Can write, will simply write 80 bytes. Okay, 800 means, so this block size is multiplication of record length and into 10. So this is like record length. So I'm just writing in short, record length into 10. So here you can see 80 into 10, it will be 800. Sorry, 8000. Sorry, 800. Okay. So like this, we have to specify the parameters to create the PDS dataset or PS dataset. Okay, now we are creating a PDS dataset. Okay, that's why I'm giving this directory block greater than 0, 20, and record format this FB. And here we have one more option, dataset name type. So here we mention the dataset name. So it will be like for PDS, we have to mention PDS especially. So for PS, we just keep it as blank. So by default, it will take as PS file. If it is PDS, we need to mention the word PDS here. Okay, so if you press enter on this screen, you can see dataset allocated here, message top right corner. Okay, so means this dataset is created. So this is a PDS library we have. So if I do F3, I came to this main screen. F3 means back. So here option 3, to see the created dataset, we have to go again option 3, utilities. Okay, from main screen, this is the main screen 3. Now we have to go to option 4. This is like to display list of dataset already present. Okay, so option 2 is to create datasets. Okay, so here, so ISPF screens we call them, right? So I give ISPF option 3.2. 3.2 means, so like if I go back here, so if you know, remember this option, you can give 3.2 directly here. You can go to this screen. You can give allocate and like this. So I'm writing in like this. So ISPF option 3.2. So 3, after 3 we have to give 2 like that. So this we'll use to create a data set. It can be PS or PDS library, PS or PDS dataset. Okay. Then we have another option we use, that is ISPF option 3.4. This 3.4 option we use to see the existing data sets. Okay. So I have created a, so I'm going to three, so I came to again primary screen here. I want to go to 3.4, so 3, then 4. Okay. So if you go to Pro 4, you can see here, just keep this as blank always. This we don't give any option here. Okay. So just tab here. So here on this, enter one of the parameters. So just always enter this dataset name level it will look like, but here we give dataset name. So dataset I have created is this one we have created now, this one, right? MATAC dot Krishna dot COBOL dot lib. You press enter on this previous screen. If you press enter, it will come next. It will show you next screen. Okay, so here, so we edit the data set. So edit or browse or view. We have line commands. So you can see both two command prompts here. So one is this. This is main command line, and this is line command. So here we have line command edit. Edit E for edit. Okay. So we have to create the member. Member means it's a COBOL member. So PDS library will have members, where inside members we write the program. Okay. So I'm creating a member in this library. Okay. So my member name is PGM1. Okay. In brackets, you have to mention the member name. And if you press enter, you can see, so by default, it will come like this. So you can give RES here one time. And if you press enter, it will show this screen. So this is the coding area. So this is the panel where we write the COBOL program. Okay. So initially you feel like this is complex, but once you code one or two programs, then you will be able to access these screens easily. Yeah. So this is a coding screen. You can say coding sheet. So if you do if you give command here, column COLS, or you can give COLUMNS, columns full name. You can see the column numbers will be enabled here. So this is column 1, column 2, 3, 4, 5, like that. So to write the program, we have to give I command, line command I. I means insert line, insert a row. Okay. Here I am giving I. Can you all see this I command? I am giving I. Are you able to understand
Yes,
what I'm
sir.
explaining?
Yes, yes.
Okay. So here I you will give. So you have to give the, you can insert a record here. So we need to code the program, right? So like I explained in last session, uh, so this is a coding sheet. So we call it as coding sheet. Okay. So this is a coding sheet. Here we leave 1 to 6 bytes. We leave for sequence numbers. Okay. Automatically they come. Okay. Sometimes they don't come. We can ignore that. And 7th column is for special purpose to write comments and all. And from 8th column, we have to start the coding. Okay. So now we are writing, I want to write simple program. Okay, can write simple program. So 1, 2, 3, 4, 5, 6, 7, 8 from column 8. So in column 7, I can write a comment if you want. So simple display program. So this is a comment. So if you want all, when you write all will comes on caps, you can do here caps on command, CAPS caps on. So then if you write even small, it will come caps. So then if I type again, so simple display program. So you can see all this in caps. So again, you need to come to this line and give a line command I again. So it will give one more line to code here. So we have to code the program now. So from column, this is column 7, right? This is column 7. So I have to write program starting from column 8. This is column 8. Okay, so move this. So identification. First division is identification division, right? Identification division. Okay. So here we mention the program ID, program hyphen ID dot here PGM1 is my program ID. Okay. And author we can mention. So author name I am mentioning Krishna, like that. So remaining all are optional. I am not using them. So if you want to see the keywords in keywords highlighted, you have to give here command line high on. Okay, highlight on. So it will highlight all the keywords. So and more specific, so we are writing COBOL program, right? To highlight all COBOL keywords only, so you have to give high space COB. COB means COBOL. So you can see, you can give like that also. High on or high COB like that you can give. So these basic commands I have listed here, these things. So you can refer this. Okay, this high on, high off. So caps on. To get all caps letters, caps on you have to give. To get all in caps, even you even enter in small, even you enter in keyboard small letters, it will take as caps. Okay, line comments we are just using, we are just used E for edit, right? So I am now using I for insert a new line. Okay, only these many commands we have, nothing that apart from that we don't have any other commands. Okay, so let's so these things are optional, author and all these things. So let's see. So I want to use, I don't have anything. I just want to use a variable. So data division I will use data division. Okay, so here we'll use two variables like yesterday we have seen that example, right? So we'll do same. So I want to take two variables 0, 1. So before coding the defining the variables, so for variables we have to use a section. Under data division we have sections, right? For temporary variables we use working storage section, working storage section. Okay, here I will mention the variables. So here 0, 1 is the level. This level number is used for special purpose. I will understand. I will explain this later. So now just now right now just remember this 0, 1 level number I am using. Okay, for a variable. So where a or we can say simple a variable a. Okay, so pick x 9 of 3 or 9 of 2. So value I am giving 20. Okay, so and variable b pick 9 of 2 I am giving like 40. Okay, so and then I want to do multiplication of these things. So procedure division where the actual execution will start. So here I will write this statement like compute. Compute means like calculate. So compute variable c, it is equal to a star b. So it will multiply a into b and will give the value result in c. So I have to code variable. I have to define variable c also. So here on this line, I want to have after this line, I want to define variable c. So giving here I command to insert one more line 0, 1 c pick 9 of 3 I'm giving if something that value exceeded 2 bytes. So I will get the 3 digit. Okay, so yeah, output will be like 820 into 40. So I will in that case I will get 3 digits. So that's why I'm giving where c as 3 bytes, 3 byte length. So I don't, this is output variable, right? So we don't need to give any value to this. So save here. If you give save, it's a command. Save and press enter. You can see this, whatever you coded, it will be saved here. Remember, PG1 is saved. So that's it. So I want to display. So these are all English words only. You can see compute, display. So like that, you can understand the meaning, purpose of this verbs easily. So I'm displaying display value of C. Value of variable C. I want to see value of variable C. And I want to display this colon also. So all thing, whatever you want to display, that you have to put that all in quotes. So it will be, it is called as literal. So it will come, whatever you keep there here, you can see the same as it is. If you write your name also will come as it is. It is like constant display. So here I will give the variable name. Okay, then I do stop run. So program execution will stop here. Stop hyphen run, stop space run we have. So all keywords you can see whatever are there, they are highlighted in red color. So these are COBOL keywords. So mainframe will understand these keywords only. Okay, so whatever the things like these are user defined, means we can give any variable name. Okay, the program name also user defined, and we can give any name, any other name like that. Okay, so let's see the steps of executing COBOL program. Okay, so we have 3 steps in executing a COBOL program and mainframe. So first thing is we have to code the program. So now we are done with first step. So second step is we have to compile the program. Then third step we have to execute the program. So compile the program means, so mainframe system or whatever system, any machine, any system, even any software, any system. So system will not understand these things directly. So we have to convert this program into system understandable code. Okay, so that process is done by compiler. Okay, so compilation is a process. So compilation is a process which will convert the high level language to machine level language. Okay, so the process of converting high level language means the language we understand, user understand. Okay, high level language into high level language means user written. So we are the user, right? So users. So we have written a program. System will not understand the language directly. So it need compiler. So compiler, it do compilation. So in this compilation process, it will convert the user written program, like whatever we have written, that will be converted into machine code. Machine code means machine understandable code. Machine will understand this code only. So it will be like zeros and ones. So machine will understand only zeros, ones. Any machine, any mainframe or any system, it is common. Like even basic language, C language also we code and then we compile, right? Then only we can execute. Java or anything, this is common. So this machine code is also called as object code. Okay. So we have to compile that. So for that we use a tool which is called compiler. So that tool is nothing but a compiler, or we call it as compile JCL. In mainframe environment, we call it as compile JCL. Okay. So we have existing tools. We no need to code that. We just need to use that. Sorry. If you press F2, it will split the page into 2 halves. So I pressed F2. I'm closing screens. So you can see we have 2 screens here. So 1, 2, DS list. So unnecessarily another screen was open. I'm closing that. Okay. So saving, and so I need compiler to compile this program. I need a compiler. So we have compilers, existing compilers. So I have some other library where I have compilers. Okay. So similarly, these are all the libraries. So if you, I'm going back. So this is main screen, right? If you go to option 3 utilities, and if you go to 4 list to see existing list of data sets, Here I am giving only two qualifiers here, mate ac dot krishna dot star. If you give only one complete name, you can see only that one. Okay, only this one you can see. Instead F3 I did here to come back. Here, if you give only first two qualifier and give star at third qualifier position, so you will see all the data sets starting with these names. Okay, if you press enter here, you can see these many. So there are 49 data sets total. So here you can do find command if you want to find anything. Okay, uh, so I'm finding for JCL compile JCL. Okay, find. So this is the JCL library. So I have created. So same way we have to create another library. So this is, let me see the compile JCL where we have. So do find on compile. So there are some other libraries. So let me JCL. So I will share the screenshots to follow while you practice. Okay, you don't need to worry about this remembering these screens. So once you follow the screenshots and execute the compile the program and all, you can remember easily. So no need to worry here. So I'm looking for JCL, simple JCL. This is another one. So let me get the JCL from another library. So we have default libraries, mate.ac id.jcl or J star I'm giving here. You can see, okay, this is default library. So here you can see, this is the compile JCL. Okay. So this is the compiler here. So we have to give the program name and the load library. We call it as load library. So this is the, so after compilation, so the source code, so compilation is process of converting high level language to machine code, right? So this high level language we have in source library. Okay. Source library means whatever we coded here now, we coded the program in this library, right? Made ac dot krishna dot COBOL lib. So this is a source library, and load library means so we have to create another library that is called load library. Okay. So this will contain the, this will get this machine code. Okay. Load library will be used to get the machine code. So I will create another load library which is called load library made ac dot krishna dot load lib. Okay. And for compiler, for compile JCL, for compiling, we need compile JCL, right? So for that, I need to create one more library that is called JCL library. Okay. JCL library. So as part of this course, we have 5 components: COBOL, JCL, DB2, CACS, VSAM, right? So as I explained in previous classes, going back. So this is the skill set of mainframe, IBM mainframe. We need to learn the COBOL language, which is nothing but programming language, and we need to learn the JCL, job control language. To execute this COBOL program, we need this JCL. Okay, so we learn these two in parallel, COBOL and JCL. These two we learn in parallel. Okay, so I need JCL library to have the compile JCL. Okay, so this library name I will give m8ac.krishna.jcl lib, jcl.lib I will give. Okay, so let's create these libraries Okay, so JCL lib will create same way how we created. So how the way how we created COBOL library, same way we have to create JCL library. Okay, so start, if you do start command here, you can go to main primary screen. Okay, so now we have two screens, screen one here, DS, screen two we have DS here. So if I press F9, you can swap between two screens. This is one screen where we have COBOL program. This is another screen where we have compile JCL. Okay, so here let's create another library, JCL library, or we can do one thing. We don't need to create JCL library now. For compilation, we have already existing tool. This is compile JCL. We can call it as tool. Okay, so we need to create load library to store the machine code. Okay, and okay, now we'll create a load library. Start 3 point. So start means if you go to main screen again. So we have total 3 screens now. Screen 1, screen 2, screen 3. Okay, third screen option 3 again 2. So A means allocate data set. Here again we go and give. So let's create JCL lib also. Next we have to create JCL lib. So we can create 3 libraries. So first, then we can start execution. Okay, so I'm creating JCL lib here. So we need 3 things, 3 steps we have, right? Step 1, we have to code the program. Step 2, we have to compile the program. For compiling program, we need compile JCL that already we have here in screen 2 here. If you place cursor here and press enter, you can see this is compile JCL we already have here. And we need another step 3, we have to do execution. For execution, we need JCL, execution JCL. So for that, I need JCL library. So I'm creating two now. One is JCL library to write the run JCL. Nothing but execution JCL to run the COBOL program. So here give a and press enter here. So same PDS I'm creating. Press enter, just no need to change anything. So created, this is created. And then I want to create load library. To store the load machine code, I need load library. So load mateac.krishna.load.lib. Okay, this is my load library. Here only difference between source library and load library here. In load library, you have to use record format as you unformatted. So it is machine code, right? It will be in different format. So you have to use record format u. Okay. So created. So total we have 3 libraries created now. Okay. So let's compile the program. So this is where is our source library, source program. This is our source library, right? So author, it is showing some error here, blue color. I am think this is not required, but I'm deleting this now. So you can, that is optional. So this is my source library where we have source program. This is source program, high level program, nothing but program what we coded. So this program we need to convert into machine code, means machine understandable code. For that I am doing compilation, right? So here in this way, here source lib, src lib, source library, here we have to give library name, source library name, and comma, it is there already. And so you can see here source library and source member, what is our program, what is our source member, pgm1. So it is same pgm1 we have, and then load library. So here we have to mention load library. So we have created load library just now. What is our library name? mateac.load.lib. This is our, this is we created, right? So currently it is blank. We don't have anything. Just created. So you can see no member present in this dataset. So this we give in here load library. This will be the, this will get the machine code after compilation. Machine code will be written into this library. Okay. Now this is copybook copy library. This is not required now. I will explain this later. Okay. Now we need to submit this, compile this. Compiling means we need to, this is a JCL. This is nothing but a JCL. Okay. So compile JCL, we call it as compile JCL. So I'm submitting. Submitting means executing. Submitting this to mainframe. Executing this on mainframe server. For that I have to use command sub. So it will submit and it will give the return code. So success or failure, like that. So it is giving error minus max CC, maximum condition code. 8 means there is some error. If it is 0 means that is successfully compiled. So to see that error, we have to go to spool this, take this job name. So you can see here first job statement. Here you can see left side to this job name. So yeah, we will explain the all other things in detail. Just let me run and show you output quickly now, as we are running out of time. So I will explain these things, how to see job name and all. Okay. So okay, I think I need to change the job name here. So my ID dot something we have to give here. So let me compile again, submit again. Okay. So now I can see the errors here. So we'll explain. So they will just quickly clear the errors. Okay. So this is the error. So this compute statement in the program, we have compute and display and stop run, right? These are we coded in area A. So error is that these should not begin in area A. Okay. We need to correct these errors. So area A, like in the presentation, you can see is area A. Area A is from column 8 to 11. Okay, column 12 to 72 area B. So these keywords, area A only we should have division section, these names. All executable statement, they should start from area B. So this is column, area B means it start from column 11. So after this line is column, this executable statement should present. Okay, so I am moving this to after column 11. Okay, so we are after column 11. Now we can compile, then it will. So we have 4 screens open. So if you place cursor under this screen name and press enter, you can go to that screen. So I'm submitting this compiler again. So you can see max CC 0 means successfully compiled. So after compilation, what is the output we get? So we get this load library will get created with machine code. So on screen 3, we have load library. So here, if you open this, V means view, E means edit, right? V for view. I want to see the data. So you can see a member created in this load library. Okay. After compilation. So if you open that view, you can see this is machine code. Machine code which we cannot understand. Machine only will understand this thing. Okay. Now we have to execute the program. So we are done with first two steps. Okay. We are done with coding and we are done with compiling. Compile the program and generated machine code. Now we have to execute the program. Okay. To execute the program, we need a JCL, execution JCL. So I'm going back from here, F3, F3. So here I have JCL already created JCL. We'll use that one now as we have less time. So JCL. So our JCL look like this. Okay. So this is our program, right? This is the program. PGM1 program name is PGM1 and we compile this program. So this is our load library. Okay. Inside this, we have this program. So you have to give this load library and program name in the run JCL. So this is our run JCL. Okay. Run JCL. So here program name is PGM1 and load library name. What is the load library name? This is load library name madeaz.krishna.loadlib. Okay. So here you have to give load library name, which is nothing but machine code present in this load library. So I will explain these parameters, other parameters. These are part of JCL. You will come to know other things. Display equals share. So if I submit this run JCL, you can see the output. Okay, submit. So successfully executed. 0 means max is 0 means success. So you can see this job name. Take this job name, and this is this area where we see the output. So I'm going back. So on from primary screen, you can see the option SDSF. So here we see the output spool. SDSF stands for spool search and display facility. We simply call it as spool. Okay, so in spool we can see the output. Spool we can see options. We can select options. ST status of jobs. Here you can see the last executed JCL. So this is our run JCL. You can see return code, maximum return code 00. First one failed, right? So this is compiler JCL output success. Now we have executed the program. Here if you do question mark, it will expand, and you can see here under sysout td name, you can see the output. So you can see the output of the program is value of variable C as 800. Okay. So what we coded here, we define a variable A, variable B, variable C, and assign the values to A, B, 20, 40, and multiplied A and B, and we are then displaying C value. Okay, 20 into 40 is 800. You can see the output here, value of variable C is 800. Okay, this is our output. So if you see here, this came as it is, whatever we give. This 800, it is nothing but printed from this inside this from the variable. Okay, C, just give C. So C is a variable, it contains this 800. So we have the output like this now. Okay, this is about this simple program, how we can display something in using COBOL program. Okay, like this. So this is simple variable. We are giving values to the program inside the program only we are giving. So in real time, we get the data from outside. We read that we get data from files. So we read those files in program and we process them. Okay, that we can can go through that files concept from tomorrow. Okay. This is simple one. So anyone has any questions so far? Okay, I will share the screenshots to navigate. You can follow those screenshots and you can navigate while practicing. Then you can understand once you execute. Until then, you feel like something new. But if it is very, like I said, it is limited syllabus, simple to learn. There are not, we don't have much to by heart or anything like that. Okay, it is like simple English like language. Okay, so I will share the IDs with you by today. I will share the IDs with you based on your available time. You can practice that. You can install the software and practice from your end itself. Okay.
Yeah, sir, can we install on our own PC?